An artisan has 63 kilogram of metal of density 7,000 kilogram per meter cube. He intends to use it to make a rectangular pipe with external dimensions of 12 centimeter by 15 centimeter and internal dimensions of 10 centimeter by 12 centimeter. Calculate the length of the pipe in meters. Now, the volume of a hollow cube can be taken to be length times width of the outer part less length times width of the lower part, all of this multiplied by the height, because the height of the parts are equal. Now volume it can be taken as mass over density. So 63 kilogram over the density of 700 kilogram per meter cubic is a volume, which should be equivalent to H into L times width times L times width. Now working out for the height, we find that the height is 1.5 meter. The diagram below represents a pillar made of a cylindrical and a regular hexagonal parts. The diameter of the height of the cylinder of the cylindrical part is 1.4 meter and 1 meter respectively. The side of the regular hexagonal face is 0.4 meters and the height of the hexagonal part is 4 meters. Take pi to be 22/7. A. Calculate the volume of the 1 cylindrical part, 2 hexagonal part. And B. An identical pillar is to be built, but a hollow center of cross-sectional area of 0.25 meter. The density, sorry for reading poorly. An identical pillar is to be built, but with a hollow center of cross-sectional area of 0.25 meter square. The density of the material to be used to make the pillar is 2.4 grams per cubic centimeter. Calculate the mass of the new pillar. Now the volume of the cylindrical part of that pillar, the original pillar, is pi r squared h. Equating in the value, find the volume to be 1.54 meter cube. Now the volume of the hexagonal part, it will be taking the base area of the 6 triangles. The base of the pillar forms the hexagonal forms, and then multiplied by the length of the pillar. Now since there are 6 and the area of a triangle is half base times height, so 6 will net off with that half base times height, so that we have 3 base height times length. Now we can find the height by taking 0.2 times 60. Therefore, the area of the base area of the hexagonal part is 3 times 0.4 multiplied by 0.2 times 60, and then multiplied by the length of the pillar, 4 meters. We get the volume to be 1.6628 meter cube. Now, part B, have been told that an identical pillar will be built, but with a hollow in it. So we shall have a hexagonal pillar like the one we have, but with a hollow in the middle. Now we know mass is equal to density times volume. So we have the density we have been given as 2.4. The volume, we shall have the previous volume of the cylinder and the hexagon. That is, if you go to part A1 and 2, we had 1.4 and we had 1.6 as the volume. So we add the two to get the volume of the original pillar and the base to be 320. Oh, sorry, 3,202,800. I've converted it from meters to centimeter. And then there's the volume of the hollow. The volume of the hollow part, we have been given the cross-section area as 0.25. So you just multiply the height. The height of it is 5 meters. So you get 1,250,000. Now, if you solve, you find that the mass is 686.42 kilogram. I've converted the grams to kilogram because we have been told to give the answer in kilogram. The diagram below represents the cross-section of a solid prism of height 8 centimeter. Calculate the volume of the prism. So the volume of the prism, we shall take the base area, which is a trapezoid in form, and then multiply by the length which we have been given, or the height which have been given as 8. We get the volume to be 72.75 cubic centimeter. The question continues to ask, given that the density of the prism is 5.575 gram per cubic centimeter, calculate its mass. We know that mass is equal to density times volume. So we had gotten the volume and we have been given the density. So if we multiply the two, we get the mass to be 418.3 grams. Now, part C, we have been asked a second prism similar to the first one, but is made of different material. The volume of the second prism is 246.24 cubic centimeter. Calculate the cross section of the second prism. Now we have the area scale factor of the two objects. Let's say the first one is A, the second one is B. Now we had gotten the area of our prism, the one we have been working it to be the volume to be 72.75, and we have been given of the other similar prism to be 246.24. So if we take the cube root of the volume, we get the linear scale factor, and if we square the linear scale factor, we get the area scale factor. So you can clearly see that say the area scale factor, we first take the cube root of the volume and then square. So if we do that, we find that our area scale factor for the object we have been working with is 17.43, and for that similar object is that 9.29. So we relate, if 17.43 is equals to 9.0 centimeters squared, what about that 9.29? So we cross multiply and find that the cross-section area of the second prism is 20.5 centimeter squared. Part 2 of C, we are told to find the ratio of the mass of the first prism and the second. Now the ratio of their mass is 2/5. Now, equating and solving, we find that the mass of the other object is 1045.7258. Now, that's a scale factor measuring the mass. We have been told is 2 to 5. So we just relate and find the mass of the other. After having done that, we know that density is equals to mass over volume. Now, having found the mass of the other similar prism to be 1045.7258, and we have been given the volume to be 246.24, we just divide and find the density, and the density becomes 4.25 gram per centimeter cube. A square brass plate of 2 millimeter thick and a square brass plate is 2 millimeter thick and has a mass of 1.0 kilogram. The density of the brass is 8.4 grams per centimeter cube. Calculate the length of the plate in centimeter. So we know volume of a cuboid is side squared. Let's say that's volume of a square cuboid is side squared times h. Now the volume is taken as mass over density. So we have been given mass as 1.05 kilogram, which is equivalent to 1,050 grams, and we have been given the density as 8.4. So divide those two, we get the volume, which should be equivalent to a squared and 2 over 10h, because the height, the thickness is in millimeters, so I'm dividing by 10 to get centimeter. I'm working in centimeter all through. So having done that, we can solve for S, and solving we find S to be 25 centimeter. A liquid spray of 384 grams is packed in a cylindrical container of internal radius 3.2 centimeter. Given that the density of the liquid is 0.6 gram per cubic centimeter, calculate to 2 decimal places the height of the liquid in the container. Now the volume of the cylinder is equals to pi r squared h. Now the volume, we get it by dividing mass over density, which should be equal to 22/7 multiplied by 3.2 squared times h. Now having equated those values, we solve for h, and we find the height is 19.89 centimeter. The figure below represents a solid cuboid A, B, C, D, E, F, G, H with a rectangular base. AC is 13 centimeter, BC is 5 centimeter, and CH is 15 centimeter. Determine the length AB. Calculate the surface area of the cuboid. Given that the density of the material used to make the cuboid is 7.6 gram per cubic centimeter, calculate in its mass in kilograms. D. Determine the number of such cuboids that can fit exactly in the container, measuring 1.5 by 1.2 meter by 1. Now we can use the Pythagoras theorem to find the length of AB. This will be AC squared minus BC squared, giving us taking the square root of the answer. This will give us 12 centimeter. Now the surface area, we shall take it by having the area of the triangles that form the cuboid, and this gives us 630 centimeters squared. Now part D, we have been told to determine the number of such cuboids that fit exactly, measuring 1.5 by 1.2 by 1. Now if you find those and you divide, you can see, just change the meters of the first cuboid and relate dividing with the centimeter of the second. Changing the meters to centimeter, relating and dividing, you find that we need 2000 cuboids of the size we have been given to fit into this larger cuboid of 1.5 meters by 1.2 meters by 1 meter. A solid consists of a cone and a hemisphere. The common diameter of the cone and the hemisphere is 12 centimeters. The slanting height of the cone is 10 centimeters. Calculate, correct to 2 decimal places, the surface area of the solid. The surface area of the solid will be the surface area of the hemisphere and that of the cone. We get 414.86 centimeters squared. The volume of the solid, we shall also take the volume of the hemisphere and the volume of the cone. We get 754.29 centimeter cube. Now the mass used to make the solid is equal to density times volume. Now we have been given the density, we have found the volume. If you multiply the two, you find that the mass is 0.98057 kilogram. A cylindrical pipe 2.5 meters long has an internal diameter of 21 millimeters and an external diameter of 35 millimeters. The density of the material that makes the pipe is 1.2 gram per centimeter cubic. Calculate the mass of the pipe in kilogram. Take pi as 22/7. Now the volume of the cylindrical part will be pi h into r squared minus r squared. This gives us 385 centimeter cube. Now we know the mass is equal to density times volume. Having been given the density of 1.25 gram per cubic centimeter, multiplied by the volume we have found, we get the mass to be 0.48125 kilogram. The mass of a solid cone of radius 14 centimeter and height 18 centimeter is 4.62 kilogram. Find its density in gram per centimeter cubic. We know that density is equal to mass over volume. Now we have a mass which is 4,620 grams. I've converted those 4.62 kilograms into grams and then divided by our volume. The volume of a cone is taken by a third pi times r squared is 14 squared times the height, which is 18. This gives us a density of 1.25 gram cubic centimeter. The density of a substance A is given as 13.6 gram per cubic centimeter, and that of substance B as 11.3 gram per cubic centimeter. Determine correct to one decimal place the volume of B that will have the same mass as 50 centimeter cubic of A. Now the density of substance A is 13.6 gram per cubic centimeter. B is 11.3 gram per cubic centimeter. The volume of A is 50. The mass is 680 gram. B, the mass we have to retain it at 680 gram. Now having a density of 11.3 and a mass of 680, what will be the volume? We make volume the subject of the formula and we get the volume to be 60.2 cubic centimeters.